The uncertain economics of uncertain climate change, the question of tipping points. My name is Kristie Sills, and this presentation is for Professor Riccardo Scarpa for Environmental Resource Economics. I will begin with a brief introduction, then the literature review, problem definition. The main issues of this presentation include modeling the economic effects of climate change and the resulting aggregate welfare impacts represented through global GDP. And then I will look at a case of climate inequity or the disproportionate environmental and economic effects of such modelings. Lastly, I will give evidence of El Niño Southern Oscillation, which is a climate tipping point. So why is climate change important? Well, because of its many causes that stem from the private and public sector, from people driving their cars or heating their houses to countries' share of aggregate global emissions release, climate change is thought of as the world's worst environmental problem. And because of the negative externalities associated with climate change, whether it be decreases in health or decreases in environmental goods, climate change was called the greatest market failure by Stern in 2007 because polluters have no incentive in the market to lower their emissions. So then people must absorb the negative and adverse health effects of climate change. So human activities obviously cause climate change, but that's not the only part of the equation. Positive feedback loops in the Earth systems, like for example the albedo effect in the Arctic, exacerbate climate change and can push the Earth systems to a critical threshold. So just to give a quick example of the albedo effect or positive feedback loop, it's what happens when something happens, something else happens and makes something worse. So for example, in the Arctic, greenhouse gas emissions build up in the atmosphere and temperatures rise, ice melts, the ocean water warms because there's more ocean surface area, and that affects global ocean currents, which may affect climates across the country, most specifically in Europe and North America. So this sort of combination is what leads to a climate tipping point. And in scientific literature, climate tipping points refers to the critical threshold at which a slight tip can alter the climate state. Such a change may be abrupt and irreversible in nature. When the tipping of an environmental system is reached, the future of the ecosystem is qualitatively altered. So, paramount economic studies for the valuation of the economic costs of climate change include Nordhaus and Falkenhauser and Toll. These studies report only small losses to the GDP. However, a growing number of studies and more recent studies are questioning these estimates of the costs of climate change by citing the nonlinearity of Earth systems. So these previous studies use smooth changes in the Earth's climate, and climate tipping points, as shown through paleoclimatic data, have already occurred, and these are not smooth changes. These are abrupt changes. So recent studies are saying that previous studies are underestimating the costs because of the omission of climate tipping points within their analysis. So a climate tipping point can be thought of a lot like flipping over a canoe. There are 3 stages. There's the tipping point, the trigger, and the critical threshold. So in the canoe, the amount of weight leaned over to flip the canoe over is the trigger. And the tipping point is the exact moment that the canoe flips over. And the critical threshold is the amount of weight or force that makes the canoe tip over. So the exact timing and the exact amount of weight to flip over the canoe is unknown. And similarly, in climate tipping points, it is unknown, for example, in the albedo effect, it is unknown how much fossil fuels need to be burned and what level of greenhouse gas emissions will cause irreversible warming of the ocean and change current systems. So this is not something that science can tell us because, as I stated earlier, these changes are abrupt and irreversible in nature. So it's not something that can be patterned or documented. So the modeling the total economic cost of climate change is either done with market strategies or non-market strategies. And principally, market methodologies are used over non-market methodologies. Benefit cost comparisons include the monetization of the adaptation and residual costs of climate change. So an example would be the cost of sea level rise. Firstly, the cost of building dikes, and secondly, the cost of land loss, which can be shown through the hedonic principle. Next, we have the enumerative method, and similar to benefit cost comparisons, the enumerative method uses climate and impact models to inform the physical effects of climate change. So sea level rise would be a physical effect, and the market consequences in the enumerative method then show the change in price or value. The best example for the enumerative method is a change in agricultural output. So this affects consumers and producers and results in significant economic losses. However, this method has been criticized because it uses a limited number of locations to extrapolate a large amount of data. So there's believed errors in this method. Lastly, statistical studies rely on uncontrolled experiments of climate change and model income and expenditure to show the effects of climate change. So this is advantageous in that it shows real-world differences in income and climate, but it is really most applicable on the national scale. So then we move on to non-market methodology, and the primary evaluation method of modeling the cost of climate change doesn't actually exist. So this primary evaluation would assess all areas in the world affected by climate change and then look at the changes in health of the people or like general changes in welfare of people. But this sort of study would be extremely time-consuming and expensive. So the default is the benefit transfer method, which is most broadly implemented by Constanza et al. In 1997 and 2014 to put a value on the global ecosystem services. So non-market assessments put a $sign on the provisioning, cultural, and regulatory services of the environment. However, the economic effects of climate change may ultimately not just be an empirical question, because the aggregation of the effects of climate change to a global scale may actually be an ethical question, which I am about to tell you why after I give evidence. So this is market valuation strategies. This table estimates the welfare impacts of climate change. Most studies use a parameter warming of 1 to 3 degrees, and IPCC consistently reports that 2 degrees of warming Celsius is expected. These studies then show the percent impact on global GDP, and most studies show very negligible amounts of cost or losses in total world GDP. And these studies report that warming up until 2100 will result in about 1 year's loss of annual GDP. And this seems like climate change is not a big deal if it's relatively inexpensive and only the cost of 1 year of economic growth. So it's important to examine why this happens. And this happens because the gains of the best off region marginalize the losses of the worst off region. So you can see losses in sub-Saharan Africa of negative 23.5 percentage points of their GDP, while gains in South Asia, 12.9 percentage points, because of the scale of economies and because the best off regions' currencies are much stronger than worst off regions' currencies. Then there's an aggregate benefit because the worst off regions, the negative consequences the negative environmental consequences don't necessarily translate into economic consequences because of the scales of their economies. So I call this a case of climate inequity because high-income countries that can be seen in North and Central America, Europe, and Asia have the greatest share of carbon dioxide emissions and will bear the least environmental effects of climate change, while low-income countries, most specifically South America and Africa, which have the lowest share of carbon emissions, will experience the worst effects of climate change. So, just go back for a moment. A case study of El Niño Southern Oscillation. So this is a climate tipping point, and basically it is a variation of temperatures along the equatorial and east central Pacific. Recently, our knowledge of ENSO has increased, and it is primarily characterized between two stages. There's a neutral phase and two extreme phases. So El Niño is warm and wet, and La Niña is cold and dry. And these sort of climatic differences have huge influences on the agricultural economy. So in this table, I have estimates of damages in the 1982 and 83 El Niño year was $2.5 billion in losses to the North America economy. And then La Niña in 1988 and 89 caused $6.4 billion in losses. So this is because the temperature and rainfall reduces output. So an example of this can be seen through losses in strawberry productions in California. So the losses stemmed to consumers was 15 million and nearly 100 million to the global share of strawberries. And while this may seem a strange example, an example of strawberries, it just goes to show that even in North America, where the impacts of climate change, the initial impacts of climate change are thought to be positive, there are already real world and real price reductions, revenue reductions as a result to climate tipping points. And so will disturb agricultural and mining sectors across the world. Countries affected include Australia, New Zealand, India, Indonesia, and Chile. And this will cause variations in, for example, in Australia, it will cause more regular bushfires, which will reduce wheat exports. In New Zealand, there will be more droughts and more floods. So, and the consequences of El Niño are systemic and have widespread problems. So overall conclusions, it is well documented that climate change will strain primary economic sectors of many developing countries and result in widespread welfare losses across the world. Evidence of the disproportionate effects of climate change materialize in such a way that the global population will experience the worst economic and environmental damages of climate change, while higher income countries, which have the global share of the economy, will experience the least effects and are projected to experience welfare gain. However, as evidenced by the ENSO case study, the negative consequences of climate change may be severely underestimated, and such positive gains reported by previous studies of the cost of economic effects of climate change may actually be underestimating the true costs of climate change. And due to the irreversibility, randomness, and global scale of tipping points, I believe, and some more recent economists believe, that most economic analysis has underestimated the preliminary costs of planetary ecosystem damage. Thank you. That is my report. Bear with me while I